MongoDB performance. As with any database, performance is a critical consideration when using MongoDB. Developers often discuss ways to optimize MongoDB performance and improve the speed of their applications. There are several ways to optimize MongoDB performance and improve the speed of applications. Here are some of the most effective methods. Indexing. Proper indexing of collections can significantly speed up queries by allowing MongoDB to find documents quickly. Ensure that all queries have an index to work with and avoid creating indexes that are not frequently used. Sharding. Sharding involves dividing data across multiple servers or shards to distribute the load of a large-scale application. It can help to scale horizontally and improve performance. Caching. Caching frequently accessed data can reduce the load on the database and improve response times. Use tools like Memcached or Redis to implement caching. Using the right data types. Use the appropriate data types for your fields. For example, using integers instead of strings for numerical fields can improve performance. Use the latest version of MongoDB. The latest version of MongoDB typically includes performance improvements and bug fixes that can optimize performance. Monitoring. Use MongoDB's monitoring tools to identify performance bottlenecks and optimize the database configuration. Hardware optimization. Make sure that the hardware hosting the database is properly configured and optimized for MongoDB. This includes things like ensuring that there is enough RAM and CPU power to handle the load. Use projections. Projections allow you to retrieve only the fields you need from a document, which can significantly reduce the amount of data that needs to be transferred over the network and improve query performance. Avoid large documents. Large documents can cause performance issues, especially when querying or updating. Try to keep your documents small and avoid embedding too many nested documents. Use the right storage engine. MongoDB offers different storage engines, each with its own strengths and weaknesses. For example, the WiredTiger engine provides high concurrency and compression, while the in-memory engine provides extremely fast read and write performance. Optimize queries. Review your queries to ensure they are efficient and use the available indexes. Use MongoDB's explain method to analyze query performance and identify slow queries. Limit the number of results. If you only need a limited number of results, use the limit method to reduce the amount of data that needs to be retrieved from the database. Optimize your schema design. Careful schema design can help optimize performance. For example, denormalization can reduce the number of joins required for queries, while bucketing or partitioning data can improve query performance. Use connection pooling. Connection pooling allows you to reuse existing connections to the database, reducing the overhead of creating new connections and improving performance. By implementing these methods, you can improve the performance of your MongoDB database and ensure that your applications run smoothly.